Assalamualaikum and welcome to my video. Right, so today I'm going to talk on the limit of a function. Alright, so which is this topic may be something new for you in calculus. Maybe you have read from the book or somewhere. Right, so never mind. Right, so basically limit of a function is written in this form. Alright, which is read as limit of fx, as x approaches a. So this is labeled by x approaches a here. Alright, so as x approaches a is k. Right, is the equation here. Alright, so this is right, and k is the value of the limit. Or you can read as x approaches a. Right, when x approaches a, so fx will approach k. Alright, so this is some things like when the value of on this graph, alright, let's say you have this kind of graph, okay, so this is x and this is the y axis, and let's say you have a function something like this. Alright, so as x approaches a, so when x approaches a, it's approaching a here. Alright, so meaning that the value of this graph is approaching this k value, right? So the fx is approaching this value, right? So this is fx. All right, so this is maybe you are not so clear about this. Never mind, I'll show you some examples. All right, so we'll divide into 3 different cases here. All right, so the first case here, okay, so we have the function where the function is defined by fx equal to x plus 1. All right, so let's say we want to find the limit as x approaches 2 of fx. So firstly, what you're gonna do is that you have to write fx as x plus 1. All right, so you write back x plus 1, which means that this fx is actually x plus 1. Where do you get this? From this defined function. All right, so what you need to do is actually you have to try to substitute with the value of the limit. All right, so the value of the limit is here. Okay, so when you substitute the value, means x approaches 2, means the value of x is 2, so 2 plus 1. So you'll get a value which is 3. So meaning to say that when you have this type of function, okay, so as x approaches 2, when x approaching 2, alright, so the value of x is approaching 2, it's not at 2, alright, it's different, you know, alright, so it's as approaching 2, so right, so the defined function will be at 3, right? So the fx will approach 3. That's what it means by the limit. Okay, so we can write as x, okay, you may write as x approaches 2, right? So fx will approach 3. The value is 3. So this is the limit, but it is different from the defined function. Let's say you want to find the value of the function at certain point. Okay, in this case, you know, if you want to find the f2, in this case, of course, 2 plus 1 is 3. This doesn't involve about approaching the value or whatsoever, but this is directly defining the function. You just substitute the value of x with 2 directly, right? So maybe this example is not much clear to you, right? So let's see this function. Okay, let's say I want to find the value of, okay, let's say firstly we'll find the substituting the function f2. Can you find f2? Okay, look at this function. This is a defined function. In the defined function where 2, the value of 2 at x is not defined there, meaning that you cannot find the value of 2. Why? Because if you substitute with 2 here, so it will become a 0 at the denominator. So something divide with 0 and it's not defined there. So that's why we define the function where x is not defined at 2. Alright, so you cannot find this. So we call this as undefined. We cannot find the value of the function. That's why there is a hole here. Alright, there's a hole there. But can you find the limit of the function as approaching 2? Of course you can in this case. Alright, so what you're going to do is that you have to find, okay, let's say I want to find the limit as approaching 2 of fx. So in this case, a limit as x approaching 2 of the function fx is actually defined by this function, right? So it will be x squared minus x minus 2 over x minus 2. All right, so graphically, all right, so you look at the graph, okay, if you look at the graph, as x approaching 2, so this will go to 3. So of course, fx will approach 3. So basically, the final answer will be 3. The limit as x approaching 2 of fx will be 3. But how do you get the value of 3? So you'll have to do some operations here, you will be learning this on the next video maybe. Alright, so you have to make the factorization. Alright, in this case, it's actually as limit as x approaching 2. This one will be actually, you have to factorize the numerator, will be x plus 1, x minus 2 over x minus 2, right? So in this case, you can actually cancel the x minus 2 with x minus 2. So leaving only with limit as x approaching 2 of x plus 1, all right? So when you substitute, so you'll have 2 plus 1 will be 3. All right, so the value is of course 3. So this is the overview of what limit is. Even the function is not defined there, you can find the limit as it's approaching that that value of x there. All right, so what if you have this kind of function? Okay, this is the piecewise function. Also, you will be learning in the next subtopics in this chapter. But never mind. The function is defined something like this, meaning to say that it's not defined at 2 using the function, but it's defined at 5. The function meaning that when the value of fx, okay, so let's say we have f2, all right? So f2 when x is equal to 2, so the value is 5. That's what it means. So that's why we have this, black hole there, all right? Sorry, the black dot there, right? So, but if you want to find the limit as x approaching, what do we call that? Okay, let's say we want to find limit as x approaching 2 of fx. So, the function is actually this function, all right? So, you have the, what do we call that, limit as x approaching 2 of what do we call x squared minus x minus 2 over x minus 2, because this is the main function here. All right, so you'll have to define that function for fx. So what you need to do is just the same as what we did before, so we have to factorize that. So you'll have something like limit as x approaching 2 of x plus 1 x minus 2 divided with x minus 2. So you'll have to cancel that. So you'll have limit as x approaching 2 of x plus 1. Right, so graphically, all right, look at the graph as x approaching 2. So which value will it approach? Of course, on this graph, it will approach this value, which is 3. So the answer is 3, not 5. All right, so you'll have 2 plus 1, which is 3. So even the function is defined at 2 as 5, but the limit as approaching 2 of the function will be 3. So the limit and the definition of the function at certain point is not necessarily the same. Okay, so I hope you get the idea of what limit is. All right, so limit is, something like when you have a function, when you have a graph, something like this. Okay, so let's say you have a function, right? So let's say as x approaching a, so as x approaching a, so the value of fx will approach this value. It's not exactly at the point at the value, but it's approaching the value. Okay, it's something like this. Next, we are gonna look at the task of finding the limits. All right, so basically when you want to find the limits, you just have to directly substitute with the value of the limit. Okay, let's say in this case as x approaching 2, so you have to substitute with 2 here. So 2 plus 5, you'll get 7. Okay, basically something like this, very easy. Let's say you have -5, meaning that the value of x will be substituted with -5. So 2 multiplied with -5 plus 1, this one is -10 plus 1 will be -9. Okay, let's say you have -1, so you have to substitute with the value of x with -1, so you'll have -1 square plus 3 multiplied by -1. All right, please be careful that -1 should be in the bracket, and then only you take the square there, so you'll have 1 minus 3 will get 2, -2. Okay, so the answer is -2. Okay, so let's look at the next one. So what if you have this limit as approaching 1, right? So there's no problem here. So it will be something like 1 square plus 2 multiplied by 1 plus 3 divided by 1 plus 1. So you will get 1 plus 2 is 3, 3 plus 3 is 6, 6 divided by 2. 6 divided by 2, of course, you get 3. Okay, you get a value. There's no problem. All right, what about this one? You substitute with 4. All right, so you will have, okay, 4 square minus 3 multiplied by 4 minus 4 over 4 minus 4. So 16 minus 12 minus 4 will be 0 at the numerator, and at the denominator will be 0. This is the problem here. Where you have the 0 over 0 case, then this is a big problem here. But this big problem can be solved using calculus. So that's why you are learning this subject. All right. So what if you have the limit of 0 over 0 case? All right. So you cannot directly substitute with this with the value of the given point, meaning that you cannot do this kind of method. What you have to do is that, okay, you have 3 types of 0 over 0 case. All right. The first one will be factorization. Meaning to say that you have to factorize as what we did in the previous example. So you have to factorize and so on, and then you can try to solve the value of the limit. And then you have the type of conjugate. Conjugate means when you have this type of radical or the square root there. So you'll have to multiply with the conjugate, where the conjugate, if some of you have learned in MAT183, the conjugate of these, what do we call this term will be square root x plus 3. All right, so square root x plus 3, and then you have to perform some operation here and simplify, and then you can solve the limit actually. All right, so never mind, you don't worry, we'll look at this in detail in the next video. All right, and the third one will be squeezing theorem, where you have limit as it's approaching 0, where sine of 2x over 2x. All right, so if you substitute with the value limit of sine 0 over 0, so it will be 0 over 0 case. So you cannot solve this by using this, but you have to use the squeezing theorem, where if the squeezing theorem in this case will give the value is 1. But how to get it is 1? Later on in the next video, we'll look at this, subtopic of each of these subfactorization, conjugate, and squeezing theorem. But bear in mind that if you have the limit of 0 over 0 cases, so you have these 3 types of, 3 types of solving limits. The first one is factorization, conjugate, the second one, and the third one will be squeezing theorem. All right, so please check out my next video for these 3 types of limit. Thank you.